Okay, so here I've got, I'm talking about the mineral ilmenite, and we actually get titanium from it to use in industry and for all sorts of applications. If we looked at a sample of ilmenite, you'll notice that it gives me masses now. So whatever our sample was, there were 5.41 grams of iron, 4.64 grams of titanium, and 4.65 grams of oxygen. And we want to find the empirical formula. Notice how they gave us masses from the beginning. Now in the previous problem, they gave us percentages that we had to convert to masses, making an assumption of 100 grams. If you are given mass, you can start with mass, okay? Because that mass there, you can get straight into moles without having to change anything else, okay? So here, I'm going to maintain that whole different color for each element so you can see what we're doing. I've got 5.41 grams of iron. I've got 4.64 grams of titanium. And I've got 4.65 grams of oxygen. Okay, I can use my mass of iron and get to moles of iron. Okay, I want to cancel out my grams and get to moles. And I know that I can use molar mass of iron, so 1 mole of iron has a mass of 55.85 grams. Okay, that will cancel out my grams of iron, give me moles of iron. I probably should have left more space since I like to keep 4 decimal places there. Alright, here for titanium, I want to get out of grams of titanium and into moles. Okay, so look at titanium. 1 mole weighs 47.87 grams. My grams of titanium will cancel and I'll be left in moles of titanium. Okay, I can come down to oxygen, and I know that 1 mole of oxygen weighs 16 grams. So my grams cancel, and I'm left in moles of oxygen. All right, let's do the math. So if I have 5.41 grams of iron, 55.85, that means that I've got 0.09687. Okay, here I went to 5 decimal places. It's just because there's one of them is a 0, so I kept up something called significant figures there, but it doesn't really. You could have rounded that up to a 9, and it probably wouldn't have changed your answer too much. Okay. All right. Here for titanium, got 4.64 divided by 47.87. So 0.9693, oops, there's a 0 there, excuse me, moles of titanium. And then for oxygen, got 4.65 divided by 16. And for oxygen, that's 0.2906 moles of oxygen. Okay, if I find my lowest number of moles, okay, it's not going to be oxygen, all right. If I look at iron, it's actually the one with the least number of moles, so I'm going to divide everything by that number, so divided by 0.09687 divided by 0.09687 and divided by 0.09687. Okay, this is going to give me 1 mole of iron. Okay. If I look at titanium, it should be really close to 1. These are almost identical numbers, but go ahead and plug it in just to be safe and make sure that we're practicing taking the moles of each substance and dividing them by the fewest moles. So 9693, I didn't even do any math, divided by 0.09687, and you see how that's 10.0000. Yeah. That is, excuse me, 10 moles of titanium. If I look at oxygen now, I'm going to have 0.2906 divided by 0.09687, and that's roughly 3. Okay. Alright, so here that means that if I have 1 mole of iron in my compound, there's going to be 10 moles of titanium and 3 moles of oxygen. That looks like a 10, so moles of oxygen. Okay, that's one word, that's the symbol, sorry about that. Okay, so now I can take these elements, and I generally, like especially since this isn't, excuse me, the bell rang, give me just a second. Okay, so because they gave me the elements in this order, I'm just going to write them in that order for my chemical formula. That's, I guess, just the best way to go when you're doing these types of problems. So my formula, for my empirical formula at least, that's what we're solving for, is going to be FeTi10O3. So I've got 1 mole of iron, 10 moles of titanium, and 3 moles of oxygen.